Okay, thank you, Martin, and thank you to the organisers for the invitation to present. My name is Mark Doherty. I work for the European Space Agency. I'm based in Frascati. We have a Centre of Earth Observation in Frascati. ESA is an intergovernmental organisation with 22 member states. They work in all domains of space. I work in the Earth observation area, and I have been managing a program called the ESA Climate Change Initiative, which is bringing together hundreds of scientists from several hundred research laboratories within Europe to analyze the satellite data that's been acquired in order to build up the most accurate possible long-term records of what we actually see in the climate system from space. So what I would like to do in the next 20 minutes is just briefly explain to you something about the international cooperation framework for making these observations. Mostly what I'd like to show you is the change that we observe from space. I will not show you models. I'll simply show you what we observe. I'd like just to highlight that these types of observations are inputs to the assessment that is conducted by the Intergovernmental Panel on Climate Change. They have to be understood in a broad scientific context, not only seen in isolation. And I'll also talk a little bit at the end to explain to you not only how these observations help us understand what's happening in climate change, but how they can guide actions on mitigation, and also how they can support actions on adapting to climate change that we cannot escape, and how they can support sustainable development to have climate resilient development. There is actually a well-established and very effective international framework for making global climate observations. It starts with the Framework Convention that will be convening all the countries together in Paris, and Article 5 of that convention specifically calls for systematic operations of the globe, of the climate system. And so that's the basis. It's a statement. This convention has to be founded on scientific, hard, validated facts. There is an entity called the Global Climate Observing System, which operates under the auspices of the World Meteorological Organization, the United Nations Environment Programme, and the International Council of Scientific Unions. And essentially what that does, it identifies what measurements need to be made in order to understand the climate system. They're called essential climate variables. There are about 50 of them. More than half of them can only be measured globally from space. Certain of them have to be measured under the ocean waters, so they really require in situ. But then we have space agencies who together each have their national and international programs. They respond to these requirements of GCOS to produce this complete set of essential climate variables in order to provide the facts that the Framework Convention needs. Just to tell you where we are in Europe, basically when I was a young postgraduate student and still had my hair in the mid-70s, Europe launched its first meteorological satellite, and that was the European Space Agency who launched that. We're now building the third generation of those satellites, both geostationary and polar orbiting satellites. They're operated, they give you your weather forecasts, and they're operated by an organization called EUMETSAT. We in ESA embarked seriously on environmental monitoring systems and climate monitoring systems in the late 80s and early 90s, and we have put together a series of systems. Now we have a cooperation, and I think this is significant, with the European Union to build a system called Copernicus, which is going to guarantee long-term operational observations of the globe, and I'll come back to that later. And in addition, there are new technologies, new observations constantly being developed with a separate line, and these will later become operational. I have to mention that in this whole system, Italy has a wonderful Earth-observing constellation called Cosmo SkyMed, which provides radar observations both for security and for environmental monitoring. So here, what you see now are, it's about 8 years of observations of carbon dioxide emissions as seen from space. These space observations of this started early. That zigzag is telling you several different things. First, we see the emissions going up. This is actually what's happening. Here are the facts. The zigzag is showing you the planet working on our behalf. The oceans are absorbing almost 50% of the oceans, and the land absorb about 50%. You see this zigzag with the vegetation annual cycle. This tells you that actually terrestrial ecosystems are working for us. If they weren't doing that, we would have twice as serious a problem, and we have to understand how this system works. It's not guaranteed that this will continue forever. So understanding the global carbon cycle is of fundamental importance. Here you see the latest results from the NASA mission, which is measuring, it's called the Orbiting Carbon Observatory. And those red dots are really showing you that, yes, we have gone over the 400 ppb limit. Ultimately, what we will achieve with the next generation of these missions is a capability to monitor hotspots, to actually verify emissions based on the concentrations we measure and track hotspots. So we have a potential tool for validating whatever decisions are or are not made. Something that you all will have heard about is the changing Arctic sea ice cover. Here, this is a very long record that started in the early 70s. You're seeing about 10 years going by. There's significant variation every year. What you see is a maximum that's reached in the winter and a minimum in summer. And when we actually just look, here are the facts. When we look at the extent of the Arctic summer sea ice, what we clearly see is since the measurements started, that's about 40 years ago, until today, there has been a progressive and systematic decline. And that's in the ranging starting at about 6% per decade down to 10 to 13% at present. Something important to see, and it's typical when you're looking at climate data, is the zigzags. It goes up and down. This is internal climate variability. And that's why we need long records in order to distinguish between what is natural variability and what are long-term trends. What you also see is not only has the summer minimum been decreasing, but the maximum in winter has been decreasing. And in fact, this year, the sea ice is at the lowest ever maximum extent. We'll have to see where we are by the time of COP, because it will have reached its minimum during the summer. So what does this mean? From a scientific point of view, that is the smallest ice extent reached in 2008. The ice is radiating back incoming sunlight to the Earth, out of the Earth, and when we have less ice, the water is absorbing the heat. This is a positive feedback mechanism. It's not just the effect of greenhouse gases. It's showing you, once it starts, there are mechanisms called positive feedbacks which accelerate the whole process. So there it's presented in a scientific sense. That's the climate change problem. These are the measurements from a Norwegian satellite which collects automatic identification signals from ships. This is the shipping detected in the year 2012 in the Arctic. So you can see the Arctic is not some remote place. It's actually a center of activity and a center of development. A lot of the activity off the west coast of Greenland is linked to oil exploration. You see all that shipping coming out of the Russian ports down around Norway. It's a hive of activity, and I think these two simple observations, I think, pose the problem that we face, is how to have sustainable development in the face in dealing with climate change. Measurements of temperature have been done historically for hundreds of years at individual locations which have kept long-term records. Measurement of the oceans were done over ships with buckets and thermometers, and they've been improved. There's been a lot of effort done to actually calibrate that data. They've been improved with a system of floating buoys networks that was embarked in 2000. But here you see what the satellite sees. And when you combine these two data sets together, you get all the details in climate quality data of what's actually been happening in the oceans over decades. If you look at the global average sea surface temperature since we began satellite measurements of sea surface temperature in earnest, and I'm proud to say that Europe really led the way here in launching in the early 90s a series of satellites that were designed to measure with the accuracy and stability needed to distinguish these long-term trends from internal variability. What you see is essentially what Martin was describing before: change on the ocean surface at a rate of the order of 1/10 of a degree per decade. And that's systematic. You also see the internal variability on the ocean surface. But what I can say is when you then look at the subsurface measurements and measure the total ocean heat, you see that 90% of all of the energy that's coming into the Earth system is stored inside the oceans. And since those measurements began, the total energy, excess energy that's been stored in the oceans, as reported by the IPCC, as being in the order of, I think, 200 zetajoules. That's more energy than there is in all fossil fuel stocks in the world. And it's going up, and it's in the ocean. Those are facts. Sea level rise is a concern to many countries around the world. Here in Italy, you have wonderful, I think people were talking earlier about the cultural heritage. You see it's threatened by sea level rise. If we actually look at what satellites have seen there in the last, again, this is starting from 1991. Here you're seeing the change in global sea level rise that has been measured by a series of satellites carrying instruments called radar altimeters. They measure the height of the ocean surface. They measure it very accurately. Each one of those colors is a different satellite with a different space agency operating it. They all tell the same story. Global sea level is rising at 0.3 millimeters per year, persistently. But it's not rising at the same rate everywhere. When we actually look at the distribution of sea level rise, those red areas are showing you sea level rise that's 2 or 3 times higher than the average. And what you see is there are certain areas of the world that are much more exposed right now to the consequences of sea level rise. Mostly the peak is in and around the East Pacific, the Philippines, these areas. It's interesting to note, for example, that in the west coast of the United States, they're experiencing mild decrease in sea level. So it's not uniform, and it's not, all countries are not exposed to the same degree of risk from sea level rise. What's causing the sea level rise? Primarily, it's the ocean heating, all of that energy being stored in the world's oceans, but it's also coming from the melting of the ice caps and the glaciers. And for the IPCC report, there was a major effort made to actually put an inventory of all glaciers in the world. Here I'm showing you a glacier in Chile, the Inesperado Glacier, and you look with images taken from 1986 through to the 1990s up to date. If you look in the center, watch the glaciers. That's 2000. That's where we are today. I think I'll play it back. If you look at that, I don't think you need to be a scientist to understand what's happening. It's quite clear. Retreat of the glaciers, creation of glacial lakes, remodeling of the landscape, and it's happening in front of our eyes. This is one glacier. The advantage of global monitoring is you can monitor 170,000 glaciers all around the world and make a balanced judgment of what is happening. And if you read the summary of the IPCC, Working Group 1 report, it tells you clearly it's systematic retreat in all areas of the world with very few exceptions. Let's go. The Antarctic. What's happening in the Antarctic? Here you see the changes observed on the Antarctic ice sheet over a period of almost 20 years, ending in 2012. These measurements were made with a European satellite, and you actually can see the red is showing you that in that period there's been a change in the thickness of 10 meters, and in other areas you have increases in the thickness, and that's primarily due to snowfall. Now, those measurements are made by a whole series of instruments, and we in ESA and NASA brought together, prior to the last IPCC report, we brought 40 scientists from 25 research laboratories on all sides of the Atlantic together to put their measurements and make an overall consistent assessment of what's been happening on the ice sheets. And basically what they show you is there has been, Greenland is producing the greatest mass loss, the biggest contribution to sea level from the ice sheets at present. Antarctica less, but you see it's systematically increasing. And again, I don't think you need to be a scientist or a member of the IPCC to think we need to know what's happening here in future. Global land cover, changes in land cover are major contributors to emissions. As I said before, terrestrial ecosystems are working on our behalf, removing greenhouse gases from the atmosphere, and satellites are essentially a unique way of gathering this information. Here you see what's actually happened over since the 80s in Brazil. Green is the tropical forest, the purple areas are agriculture, and you basically see the progressive removal, deforestation, replacement with agricultural cultivation. A lot of people talk about the deforestation in the Amazon. It's happening right across the tropical forest regions. There is a major initiative as part of the Framework Convention called Reducing Emissions and by Deforestation. And Earth observation, again, is an important tool in doing that. Brazil has used satellites since the late 80s to monitor its forests. They're very professional, very efficient, and they succeeded with the addition of a national law from the mid-2000s onward to actually effectively reduce their rates of deforestation using this suite of tools. Unfortunately, some of those deforestation rates have gone up since then, and that's probably the result of political change. It's certainly not science. Its capacity building is really important. It's fine to have all of this data, but actually people need to be able to use it. And here we had a perfect example where Brazil worked with FAO here in Rome to help the Democratic Republic of Congo set up a similar system so that they can monitor their own forests using the same tools. There are all types of change in land use, and here you're seeing from 1975 what we've seen with satellites in terms of urban expansion and urban development over Shanghai. That's about 70-kilometer wide area you're looking at, and it basically where you had agricultural natural land before, it's basically now cities. It's concreted over. This, by the way, cement manufacture after fossil fuels is one of the major contributors to emissions. What is happening here is setting up a massive urban heat island with its own climate regime, and it's highly subject to risks of heat waves. And it's not just in Shanghai. This is happening in all of the mega cities, and it's happening in Europe as well. So we can get this information from satellites and hopefully use some of it to improve planning and at least take a measure of the problem. These are some examples of the sorts of observations, the facts that the science community is bringing forward and laying on the table. This is taking satellite data from different space agencies, and the scientific results are integrated in a complete assessment. That's what the IPCC does. It takes historical data, it takes the satellite observations, it then uses that with climate models, and it uses the data to verify the models, and on that basis, projections are done. It's an enormous exercise, but that's what's behind the scientific recommendations that are going out and that are basing the decisions that have to be made. So having said that, I'd just like to point out that the observations are not only telling you about the science of what's going on, they're also guiding you in taking mitigation actions. Actually, quite like what Francesco Rutelli was describing for ozone. It's exactly the same process. You have a policy decision, everybody decides to do something. Well, that's not good enough. You need to know 5 years, 10 years, 15 years later what's actually happening, and that's how one of the critical ways to assess that any policy agreement really takes effect. And sometimes, as happened with the Montreal Protocol, you have to adapt your mitigation measures. So there is a major initiative to ensure that all the data necessary for all countries to do this themselves will be available. There's also another major initiative undertaken under the framework of the World Meteorological Organization to develop what are called climate services, and particularly in developing countries, to take the satellite data, information on technology, methods, and make this available in developing countries, which will be the ones that will actually feel this first of all. And the issues that are being dealt with, it's not climate change, it's agriculture, food security, disaster risk reduction, water, and health. All development issues. In ESA, we've been working with as an international organization with the major development agencies to help them mainstream this type of information into their development programs. And the message really is, again, the bottom line. Once again, this requires a lot of capacity building in the developing countries, and it can only really be done by partnership between development agencies, technical agencies, funding agencies, but it's a key element of equipping these people with the capacity and the technology to use the information. And it's very important for those countries that they do it themselves. They do not want a bunch of people sitting in Europe or North America monitoring their forests, monitoring their agriculture and telling them what to do. That just doesn't work. We have to transfer this technology along with all of the other technologies into their hands so that they have the tools to help them make appropriate decisions. This is unfortunately another use of Earth observation. It's an example of something called the International Charter for Space and Natural Disasters, set up in 2001 by the European Space Agency and CNES, and now with 10 or 15 space agencies involved. When countries are confronted with natural disasters, they often don't know what is actually, their map of their country has been redrawn. They don't know where the floods are. They don't know where to send the relief agencies. And space agencies together, when they get the call from countries in this situation, immediately switch their satellites to deliver the data and equip these people and relief agencies with the information required. This is the Mariana Islands, which were struck by Tropical Storm Dolphin within the last few days. And unfortunately, 60% of these disasters that we deal with are related to floods and storms. We're also dealing with earthquakes, other sorts of events, but this is showing you the link with climate change and these issues. Finally, I'd like to draw your attention to the fact that Europe is not only making policy, it's backing its policy up with substantial means to actually gather these facts. The European Union and ESA have been building a system called Copernicus, which We'll be launching in the next, actually we're launching one of these satellites within the next month. Constellations of satellites monitoring the Earth with radar systems, looking at the atmosphere, looking at the oceans, looking at the land change. They will assure Europe with the data it needs at least for the next 20 years. And combined with the meteorological systems, this is a very powerful and essential tool. But something that is equally important is the thing at the bottom, free and open data policy. This is an investment exceeding 5 billion euros. And all of the data that is acquired will be freely available to anyone who can get it and use it. And I was personally involved in making the socio-economic benefits analysis of an investment in the system. And the basic conclusion was, if we want benefits for Europe and benefits for everyone, the best way we'll get that is just get this data out into people's hands, let them be informed so that they will be informed and make better decisions. And if people make better decisions, it will benefit everyone, whether they're in China or in Africa or in Europe. So I think this is a major investment, and it shows you the commitment of European governments to actually back its policies up with the technical means. I have to say, I personally regret that this type of technology is not sufficiently recognized inside the Framework Convention, although there's a standing issue on systematic observation. The actual transfer of this technology and the capacity building that's required, I think, should be recognized as an important element, along with the energy efficient and clean technologies. So, to conclude, I guess some of these statements are obvious. Probably the most important one for your discussions is just that based on the facts, we see significant global trends in satellite observations since the 1970s. We see rising sea levels, we see reducing Arctic ice, we see melting ice sheets, we see increasing sea surface temperatures. These are facts. You can see them with your own eyes. The assessment of what the implications of these are and where we will be going in future, it has to be done, I said, in conjunction with other measurements and models. And where we will go will actually depend on what we decide to do in terms of our emissions. But there's one thing that I can say with absolute confidence. If there is a decision that is actually acted on in Paris, we will need these tools in order to assess what's happening, to guide the implementation of our policies. And if there is no decision to implement, or if there's a decision which is not implemented, we need these tools even more, because the discussions will need to be based on hard facts as we see these changes continuing. So with that, I'd like to again thank you for the invitation. And I have to thank all the scientists who did this work, because this is the work of hundreds of scientists, and I have the privilege to present their work.